Excellence, maybe I should start in French in 2 words. Excellence, mesdames et messieurs, chers étudiants, chères étudiantes, je profite de dire quelques mots en français puisque cette conférence coïncide avec le début du semestre de printemps de notre université et qu'il s'agit d'un moment important puisque nous reprenons les cours dans cette université avec la levée des mesures sanitaires. Et donc, c'est un plaisir de revoir tous les visages de tout un chacun dans la maison. Excellencies, ladies and gentlemen, dear students, it is a real pleasure for me to welcome you today for this conference on climate change. My name is Christine Cadus. I am professor of European law at the University of Geneva, and I have the pleasure of running the Center for European Legal Studies, in French, Centre d'études juridiques européennes de cette université. And at the same time, I'm running also a master degree, an executive master, the Master in European and International Governance, MEIG program. And this conference is organized because it is also the first day of a module within that MEIG program on climate change. We have a 2 weeks module on climate change that we organize with the World Meteorological Organization, and this is a great pleasure, and it is a real success every year now. So the topic of the conference is, of course, of utmost importance today. I don't need even to underline this. Climate change is having impact on every day. The situation is difficult, dramatic. I know that our speaker probably will not use such dramatic words about climate change, but we will listen to him afterwards. So the topic climate change has to be at the center of all activities, on all governance issues here in Geneva, in the international Geneva, but all around the world. Who best than the patrons, we say in French, or the boss, we could say, of the World Meteorological Organization, or more, I would say, professionally, the Secretary General of the World Meteorological Organization. So it's a pleasure to welcome Professor Peter Taalas today for this conference. The conference will be of about 1 hour, and a discussion afterwards with questions and answer after this. So a few words on our speaker. Professor Peter Taalas was born in Finland, and he made I would say, a first career at university level. He is professor of physics. His PhD was in meteorology, physics of meteorology. So he was teaching, as myself, at university level, and he did a wonderful career in Finland. He was director of the Finnish Institute for Meteorology for many terms. He did also an international career in different international institutions, always doing with meteorological issues, if I may say it like this. And he was appointed as Secretary General of the World Meteorological Organization in 2015 for a first term, and he was renewed in 2019 for a 4-year period. It is quite interesting to see that kind of profile, because coming from, I would say, a physician in meteorology, having, I would say, an academic career, international career, and going to governance issues. And you can see why I'm saying this, because, of course, governance is today one of the main elements and, I would say, features to look at different challenges. Professor Taalas is, as you will see, an expert, of course, in all the climate issue, but he will also tell us how to manage these challenges, or how to try to manage these challenges, and what are our future in that specific field. So thank you very much for being with us, and Professor Taalas, please have the floor.
So good morning, everybody, and it's a pleasure to see you here. And besides the students from all over the world, I'm happy to see also ambassadors and people from the missions of Geneva, and also other people from the university present here. So welcome. And I understood that this is the first day after holiday season, and hope that you are all full of positive energy. And the Swiss government has decided to open everything, and hopefully this COVID pain is now over. So I will tell you about climate change, disasters, and briefly also what WMO does, and how the perspectives for the future look like. There has been lots of efforts for climate mitigation. For example, we had the Glasgow climate conference in November, and we are just preparing for the next one, which will take place in Sharm el-Sheikh in Egypt, and United Nations is very active in this field, and also my friend Antonio Guterres has always said that climate mitigation is his highest priority as the Secretary General of the UN. Christina was already telling you about my background. So I have been Secretary General of WMO for the past 6 years, and before that I was leading National Research and Service Institution, and before that I was a real scientist before becoming a bureaucrat. And I have been also dealing with private sector. I used to be a member of board of directors of an energy company, which is nowadays about the third biggest energy company in Europe, and it was very interesting to see the things from that perspective as well. So WMO is a UN specialized agency on weather, climate, and water, and they are of course all fairly hot topics besides Ukraine, which may be the hottest topic at the moment, but in the long run these are the key issues. And almost all of the UN members are also members of WMO, and we have been placed in Geneva, and we are the second oldest United Nations organization. Next year we will celebrate 150th anniversary of WMO. The telecommunication unit organization is a couple of years older than us. And most of our work is done by our member countries, and we have more than 300,000 experts at the country level who are dealing with our issues. They are coming from meteorological, hydrological services. They are coming from universities, research institutions, and nowadays also growingly from private sector. And private sector, for example, Microsoft is nowadays very active in our field. They are offering IT services and cloud computing services, which are needed for both climate science and weather forecasting business, as example. And then IPCC, which is just about to release its new report actually next Monday, and I will also participate in that event. And Secretary General Guterres will also come for the press conference next Monday, when we launch the report on the impacts of climate change. I will tell something about that, but I will not show the results of the report yet, because it's still under discussion, some wordings in the document, but the main results are fairly well known. And in the UN, we have Secretary General Guterres' climate core group, and I'm one of those members, besides my colleague from UNEP, UNFCCC, and UNDP, and we are very much giving guidance to Secretary General Guterres, and this afternoon we will have one of our meetings. At WMO we have carried out major reforms during my term, and we have started thinking of Earth system instead of thinking of weather, climate, and water, and various services and ocean issues as separate items. And we have also opened the doors much more for the academic sector and also for the private sector. As I said, private sector is playing very important role in our case. And we have also made changes in our staffing. We used to have lots of support staff, and nowadays we have hired lots of young experts to WMO to strengthen our scientific and technical skills. And climate science communication is one of our key issues, and we are providing status of climate reports on annual basis, and together with other UN agencies we are publishing before the General Assembly major climate reports for the heads of state. And climate is nowadays very hot topic in other organizations, and we have lots of partner organizations. For example, the United Nations Disaster Risk Reduction Organization moved to the same building with us some months ago, and you can see that many other organizations are dealing with the issue. And then we are also dealing with transportation. Aviation is not possible without our contribution, and same is true for maritime transportation. And we have been able to release more money to support our less developed countries. And the special feature of WMO is that we are working like a family organization. We are freely exchanging data, but we are also freely sharing know-how between the developed members and less developed members. But now I will show you some slides concerning climate system, and we are dealing with the climate system in physical terms. We can measure many things that I will soon show you, and then we can also model this the behavior of the system, which is quite unique. For example, when we talk about biosphere, it's so complicated system that it's very difficult to model it. But in our case, we can handle the atmospheric behavior by using the basic laws of physics and create the models which are used for weather forecasting, but they are also used for climate scenarios to estimate what's going to happen to the climate by the end of this century or by the end of next century, and what has happened in the past. And we are living in a very nice planet, so we haven't found such a nice planet anywhere from the universe so far, despite of eager astronomers who are seeking for something similar, and there's a good reason to take good care of this kind of planet, where we have water, we have oxygen, we have a biosphere, and we have also atmosphere, which is transporting both heat and also water from the oceans to the land areas. So this is very unique system that we are having, and it's important to take good care of that. We have measurements from of the temperature since the 1850s, and WMO has been setting standards for those observations, and we have somehow worldwide coverage since 1850, and we can estimate what has happened to temperature since those years. And here you can see a graph which is showing that there has been clearly a warming of the planet, and so far we have seen about 1.2 degrees warming, and we are approaching this low limit of Paris Agreement, which is 1.5 degrees. And here on the map you can see what we have been observing during the past 5 years as compared to the long-term average, and all these reddish and yellowish colors indicate warmer temperatures than the average, and you can see that especially the Arctic has warmed the most, but also the continents in Europe, Asia and Africa are having lots of reddish color. There's a special feature south of Greenland and Iceland cooling area, which is related to slowing down of so-called Gulf Stream, which is bringing warm air from the Caribbean towards Europe, and that's one thing that we have to follow, because that may have a negative impact on the temperatures in Europe. But so far we have seen fairly dramatic warming taking place over the continents. And also the Antarctic area has started warming, and there we have 60 meters of ice, and we have ice for several kilometers, and if we would melt that, we would see sea level rise of 60 meters. So that's a big thing to be followed. And you saw that there were some variations in temperature, and we have so-called La Nina, El Nino variability, which is having an impact on the ocean temperatures, especially in southern hemisphere. And once we have El Nino years, a strong El Nino, last strong El Nino year was 2016, and then we broke all-time high in temperatures, and since then we have had more these La Nina years, which indicates colder temperatures of the ocean, and we haven't been breaking the record. But next time when we see El Nino year, it's very likely that we will break the record again and be already fairly close to the 1.5 degree, which is the lower limit of Paris Agreement. And last year we saw several temperature anomalies. We broke all-time high in Europe. In southern Italy we reached 48.8 degrees, and in the Arctic, especially in Russian Arctic, we had third year of 38 degrees, which is very unusual in the Arctic area, and also in Western Canada we broke almost 50 degrees record, which is clearly a very high thing. And in the ocean areas we had again this La Nina year, which was where you can see lots of bluish color, which was colder than normally. And we have, as I said, we have observations of the temperature for the past 150 years, but before that we can use indirect methods to estimate how the temperature variation has been. We can use tree rings, we can use some sediments in the oceans and so forth, and get estimate what has happened during the past 2,000 years, or we can even go back several millions of years by using certain techniques. It's more uncertain, as you can see, this grayish area here, but what has happened during the past 100 years is quite unusual. So we were supposed to go towards next glaciation period with the cooling of the planet, but we have seen fairly dramatic increase of the temperature. And we have already exceeded the variability for the past 100,000 years. There has been natural variability which has been caused by the position between sun and earth and tilting of the earth, and which has led to this glaciation variability, and we have already exceeded such natural variability. We have measured the carbon dioxide, the methane, and nitrous oxide concentrations, which are the three main greenhouse gases which are causing warming of the lower atmosphere and ocean. And we have a chance to estimate what has happened during the past 800,000 years by drilling the ice cores of Greenland and Antarctica. And we have also exceeded this natural variability range heavily, and here you can see what has happened during the past decades, and we have been breaking records of those concentrations year by year. And last year we had this, and 2020 we had these COVID lockdowns, and we were expecting to see a slowdown of this trend, but we have still seen an increase of carbon dioxide concentrations despite of the 1 year anomaly in the emissions. And this is because of the very long lifetime of carbon dioxide. And this is what happened to the emissions. The emissions have been growing. There was some sort of plateau after the Paris Agreement in 2015, but thereafter there was a slight increase again, especially coming from big economies in Asia, China, India, Indonesia, Vietnam type of countries. And this drop of 5.6% last year didn't change the big picture because of very long lifetime of carbon dioxide. It's more than 100 years. And here is an estimation what has been the impact of various gases for the warming so far during the past 150 years, and out of those, carbon dioxide is responsible for 2/3 of the warming. Methane is in charge of about 1/6 of the warming, and nitrous oxide 7%, and then we have ozone-depleting gases, which are also greenhouse gases. And the difference between carbon dioxide, which is very much coming from the fossil fuels, oil, gas, and coal, and methane, is that the lifetime is very different. The lifetime of methane is 11 years, and methane is very much coming from the tropical wetlands, from cows, and also from rice paddies, but the lifetime is 11 years, whereas the removal of carbon dioxide from the atmosphere takes up to thousands of years. Its lifetime is more than 100 years, but it's very slow to remove carbon dioxide from the atmosphere. So that's the main problem that we are having. And here you can see an estimation of the carbon budget. So which factors are causing increase of the carbon in the atmosphere, and which factors are sinks of carbon, and the rest remains in the atmosphere. And you can see that until something like 50s, 60s, land use was the dominant one. It was very much deforestation worldwide. It was very much related to the farmland issue, that we were building more farmland by cutting forests. And since then, this fossil carbon has started dominating this, and at the moment, almost 85% of the problem is caused by use of fossil fuels, oil, gas, and natural gas. And about 1/4 of the extra carbon that we produce to the system is taken by the oceans, and this ocean sink has been increasing, and there are some theories that once we heat the water, the sink is getting weaker. It's not growing as it has been doing so far. And land sink, that's very much forests that are absorbing carbon from the atmosphere. That has been also growing, and the rest remains in the atmosphere, which is this light blue area. And it has been growing, as you can see. And we have stored more than 90% of the extra heat that we have produced to the planet to ocean, and oceans have been warming. Here you can see various depth of the ocean, and it's happening in the whole water mass. And at the same time, since oceans serve as a sink of carbon, we are changing the chemical composition of the seawater. It's getting more acid, and there's an estimation that the ocean acidity hasn't been so low since for the past 20,000 years. And this is a long-term threat. If we continue this trend, it's going to affect various ocean ecosystems, and that's again one reason to reduce the consumption of fossil energy. There are some discussions going on so-called geoengineering, where we could, for example, inject sulfuric acid to the stratosphere and start covering the planet and cooling the planet by doing so. But this would mean that this ocean acidification would continue, and if we would inject sulfuric acid to the stratosphere, it would also cause global acid rain, and also change the behavior of atmosphere. There have been some institutions worldwide who have been promoting this geoengineering, and from atmospheric science perspective, that's not a healthy solution. But if we are able to create carbon removal technologies, that would be most welcome. And this geoengineering issue may be discussed at the political level during the coming year or so. Sea level rise is also one of the things that we are observing from stations, but nowadays very much from satellites, and for example 20 years ago the sea level rise used to be about 2 millimeters per year, and nowadays it's exceeding 4 millimeters per year. And there are two main factors behind this. One is that once we heat the ocean, it's thermally expanding. That used to be the main factor still some years ago, but the glacier melting, especially the Greenland and Antarctic glacier melting, they are contributing to the sea level rise. And we have already exceeded such level of carbon dioxide that we expect that this problem will persist for the coming hundreds of years anyhow, independent of our success in climate mitigation. And IPCC published its physics report in August, and there they estimated what's going to happen to the sea level rise by the end of this century, and what's going to happen to sea level rise by the end of next century. And these estimates are now higher than they used to be, and that's very much because of the speeding up of melting of Greenland and Antarctic glaciers. And the estimate now is that if we are able to reach 2 degrees, which is this dark blue curve here, we could see something like a half meter to 1 meter by the end of this century as sea level rise, and from half meter to 3.5 meters by the end of next century. And if we are not successful with climate mitigation, we could see this reddish bar by the end of next century, and we could see typically 2 to 7 meters of sea level rise. And this is going to be a challenge anyhow. We have lots of low-lying areas worldwide. For example, the big cities in China, Singapore, Vietnam, Thailand, India, several African areas, several European cities like London, for example, Copenhagen, New York, Los Angeles, Buenos Aires. They are all sensitive to this increase. And what is the challenge often is that we have first this overall sea level rise, and besides that we can have a storm system which is leading to temporary sea level rise, and we have seen such things happening already, for example, in New York. The southern Manhattan was some years ago, a couple of weeks flooded, and the subway system was flooded for more than a year. We are very much talking about global warming, especially in English language, and that's a little bit the misleading term, because the biggest impacts of climate change, they are perhaps not felt through temperature increase, but changes in the precipitation patterns, and also this sea level question. And here you can see what has happened in the long run. The global precipitation. Here is a comparison of past decades with the early parts of last century, and these brownish and yellowish colors indicate the decrease of rainfall amounts, and greenish increase of rainfall. And you can see that, for example, Africa, some parts of Latin America, and Eastern Asia have become drier, and typically the high latitudes have been becoming more rainy, and this is having even bigger impact than the temperature changes. And also last year we had rainfall anomalies, and some of these rainfall anomalies were related to these heat wave events, and for example in western USA and western Canada we had both drought and heat wave at the same time, which led to forest fires, and we have seen such things happening also in the Mediterranean region here in Europe, and also in Latin America, especially the Amazonian region has become such region where we have started seeing more often drought events, but then some in the northern parts we have seen also flooding problems, and Eastern Asia has faced the flooding problems. I will come back to the casualties soon. And here you can see some numbers. What we have seen, there were more than 1,000 casualties in India caused by flooding, 350 deaths in China, and also here in Europe, in Germany and Belgium, there were about 200 casualties. And we have been, by warming the planet, we have more humidity in the atmosphere. When it rains, it often rains more. So it has enhanced the rainfall amounts, and this is causing flooding problems. And this warming of the Arctic area has changed the general circulation system of the atmosphere, and we have started seeing more often these kind of stagnant weather conditions, persistent heat, high pressure systems, which is causing heat waves and drought in summertime, and cold spells in wintertime, and that means that the low pressure areas are having often the same tracks. So, and that was, for example, the problem behind all of those flooding events, that there were rains coming day by day, and finally it was too much. So this Arctic warming has had an impact on the global atmospheric dynamics. And we have already been able to show from scientific perspective that this heat wave and drought in Western North America and the flooding event in Western Germany wouldn't have been possible without the impact of climate change. So that's something that we can already show, that these kind of events would have been very unlikely without the impact of climate change. And I have been using analogy to sports. We just finished the Beijing Olympics actually yesterday, and the athletes, they are high-performing individuals, but once you dope them, they can perform even harder, and we have been doping the atmosphere. So we have had these kind of variations in the past, but because of this doping, especially use of fossil fuels, atmosphere is working more effectively. And one of the consequences that we are talking about is food security, and this is very much dealing with the drought problem. And here you can see statistics from FAO. There has been a nice development in the past, that we have seen less and less people who have been suffering because of lack of food, but during the recent years there has been an increase, and this is partly caused by climate change, and this trend may continue in the future, because I will soon show you what may happen to the global food production capacity. And if you look at some statistics, we can say that during the past 20 years, more than half of the global population have been exposed to major natural disaster. Here in Europe, it has been very much heat waves and some flooding events, but in Asia, for example, it's very much flooding. There have been 2 billion inhabitants who have been exposed to major flooding events, and about 1.5 billion who have been exposed to drought events, and that's, for example, very much a challenge in African countries and also Mediterranean region, both in Africa and Europe. And about 700 million people have been exposed to tropical storms, and that's very much Eastern Asia and Caribbean region. We published last autumn an atlas on disasters and how much people have been killed in these events, and how the economic losses have been. And the big picture is that we have seen a decrease in the casualties thanks to improved early warning services, but the economic losses have been dramatically increased. We have seen tripling of the economic losses since the 80s, and this is the impact of climate change. And here you can see some dramatic events where we have seen high numbers of casualties, and for example, drought in Ethiopia led to death of 300,000 people. We have seen flooding and storms in Bangladesh with also lots of casualties, and you can see that it's mostly developing countries who have been vulnerable in this case. Also in Russia, there were casualties when there was a heat wave in 2010 with high temperatures and also forest and peat fires with poor air quality. And here in Europe, we had a heat wave in 2003 with the poor air quality, and that led to 75,000 casualties in Central Europe, especially in France. And thanks to improved early warning services, we have been able to see lower numbers during the recent years. And if you look at economic losses, you can see that the United States is having fairly dramatic statistics here. The big economy, USA, is very vulnerable to especially tropical storms, and you can see plenty of them. Katrina has been so far the most expensive disaster, which destroyed New Orleans, and New Orleans is a place which is not the most suitable place to live, because it has been destroyed every 50 years in the past, and one should consider whether it's a good place to live. But people have started returning there, and it may happen one day again. But because of climate change, we have started seeing more often these category 4 and 5 tropical storms, and during recent weeks we have seen such things happening in Madagascar, and we have seen high wind speeds which has destroyed the houses, and also severe flooding, which has also caused lots of these damages. And globally, one can say that there has been an increase in the amount of disasters and economic losses, but thanks to improved early warning services, we have seen a decrease, and that's very much thanks to the activities of WMO, and where the rich countries are supporting less developed countries in improving their early warning services, and this is still continuing. And if we classify these disasters, as I already said, the big economies, they are having the biggest losses. USA and also China has been exposed to major losses. But if you look at casualties, Africa is very sensitive, and their drought is the driver of the losses. And in the August IPCC report, it was shown that practically the whole world is already exposed to a growing amount of hot extremes, and that's very much a health challenge. Here you can. This is global map. It looks like a little bit bee nest, but it's a global map. You can see Africa in the middle, and then Asia, Africa, Australia, North and South America, and practically all of the regions, excluding the southern tip of South America, they have been exposed to this growing amount of extremes. From Central Africa, we don't have enough data because there's a gap in observing systems. That's why we cannot say anything. But the whole world has seen this increase. And here we can see what has happened to the heavy precipitation. All these greenish parts of the world, they have been exposed to a growing amount of heavy precipitation. And as I said, when it rains, it often rains more. And this Eurasian continent is clearly the most sensitive to heavy precipitation. And this is drought, and drought is very much has been hitting Mediterranean region, and also the home country of our one ambassador from Portugal, and also in southern and western parts of Africa, you can see color, which is indicating that the drought has become more frequent, and same is true for the western part of North America. Then some more observations. This is what has happened to the glaciers worldwide. We have started losing growing amount of mass of glaciers worldwide, and besides these big glaciers, Greenland and Antarctica, we have important glaciers here in Alpine area, in Andes, Rocky Mountains, and especially Himalayan glaciers is very vital for the freshwater availability in India and China. The big rivers have their origins from Himalayan glaciers, and once we melt the glaciers, we will get less water to the main rivers worldwide. And we have countries like Peru, for example, where all of the fresh water, for example, to Lima, is coming from the meltwater of Andes. And once we melt the glaciers, we will get less and less water to the rivers. And that's going to be a challenge also here in Europe in the long run. And there's been a boost in the Greenland ice sheet melting. I don't go to the details here. And same is true for Antarctic ice sheet. And as I said, Greenland has a potential of 7 meter sea level rise globally if we would melt the whole glacier, and Antarctica has potential of 60 meters sea level rise. This is not likely to happen, but those are the big drivers in the long run, how much we melt them. And this current concentration of carbon dioxide, which is about 420 ppm, is already such high that this melting is estimated to continue for the coming hundreds of years anyhow. And this is, of course, contributing to the sea level rise, but also how much water we have in the main rivers. In Africa, we have only one glacier at Mount Kilimanjaro, and we expect it to disappear during the coming 10 to 15 years. It's very, very little ice left there. And we have seen changes in the Arctic. As I said, already showed the Arctic area has been facing the largest changes so far, and we have been melting the sea ice coverage from there, both in springtime and autumn time, which is shown on this graph. There's year-to-year variability, but the overall trend is negative, and we have melted more than 70% of the sea ice mass, and so-called multi-year ice has practically disappeared. In the 80s, we still had plenty of 4-year, 3-year, 2-year-old ice, which are shown by these bars here. But in 2016, you can see that there were practically no more this old ice left, and the ice is getting thinner, and that's why we have seen the biggest warming in the Arctic. This the radiation properties of snow and ice have been behind this fact that Arctic has warmed more than twice the global average. IMF has estimated what has been the impact of 1 degree warming on global economy so far, and it's shown on this map. All these reddish colors indicate negative impact on economies, and that's very much coming from changes in the precipitation patterns, and you can see that it's southern hemisphere and low latitudes of northern hemisphere where this has been seen. And then we have greenish areas which have been gaining economically from this change. The agricultural growing season has been getting longer, it's raining more, and the temperatures are higher, and you need less energy for heating the facilities in winter time. So world is uneven from that perspective. 4 years ago, IPCC published its 1.5 degree report. Once the Paris Agreement was signed in 2015, the countries agreed that 2 degrees would be the right target by the end of this century, and especially the island states and some LDC countries were insisting that we have to have this 1.5 also embedded in the Paris Agreement, although many countries felt that that's too ambitious. And there was a special IPCC report published 4 years ago, which was demonstrating that for the welfare of mankind and biosphere, 1.5 would be much more favored, should be much more favored target than 2 degrees. And then there was a change in the thinking, and many countries agreed that we should aim at reaching 1.5 degree target. And that was also the aim at the last COP meeting in Glasgow, and the rich countries, the G7 and European Union countries, made pledges which would indicate, which would lead to this 1.5 degree target. But the rest of the countries, these 20 countries which are responsible for almost half of the global emissions, they were not ready for that. And that's going to be the target at the forthcoming COP meetings in Sharm el-Sheikh and Arab Emirates 1 year thereafter, whether we could raise the ambition level, especially in these BRICS countries and some big economies like Indonesia and so forth. And to reach this 1.5, we should bend this emission growth curve, which is the green curve here on the left-hand side, in coming during this decade, and that's why it's important to set targets already for 2030, which was the aim of the UK government. And if we would like to reach 2 degrees target, we have 20 years more time to bend this emission growth curve, and we should become carbon neutral by 2070. This carbon neutrality means that there should be a balance between the emissions and sinks, so we can still use some fossil energy, but we have to compensate it with the sinks, which are typically forests. The good news from the August IPCC report is that this earlier estimation that if we fail with the climate mitigation, we could see 3 to 5 degrees warming by the end of this century. This is not likely anymore. I will come back to show how the situation looks like today. But we are not yet on our way to the Paris 1.5 to 2 degree targets. And also in the August report, there was an estimation of what may happen to precipitations and soil moisture by the end of this century, and what's going to happen to the temperatures by the end of this century. In the upper panel, you can see rainfall estimates by the end of this century, 1.5, 2 degrees, and 4 degrees warming case. And in the lower panel, you can see soil moisture, which is very much running the agricultural conditions. And again, 1.5, 2 degrees, and 4 degrees target. And perhaps the most important one is the lower panel, which is driving, for example, the global agricultural production. And in all cases, you can see lots of brownish colors in both Americas. And if you go to higher numbers, it will be fairly dramatic, for example, in the South American part of the world. The Mediterranean region is going to get drier anyhow, and if you go to higher numbers of warming, then the change is more dramatic. And then you can see some areas worldwide greening, and that's in Central Asia, and also the Saharan region may get more rainfall and greener. But there, the conditions for agriculture, they are not most suitable. The soil is, this sand is not the best area to grow anything. So this is one of the challenges that we are going to face. And also this increased rainfall amounts in some parts of the world, like some parts of Asia, mean that there would be more severe flooding problems. And here is an estimation what would happen with 2-degree warming, and here is a map which is combining drought, heat waves, and flooding challenges, and you can see that for example parts of the Eurasian continent is going to get hotter and wetter. Mediterranean region is going to get hotter and drier, which is bad for agriculture and also for tourism in that region. And in Africa, some parts are going to get drier, but some also wetter. And in Americas, you can see lots of these drought-related challenges. And again, world is uneven. In some parts of the world, you can see improvement basically, but globally, the estimation is negative. As I already said, water is one of the key drivers of this climate question, and we have started paying attention to that. We have created Water Climate Coalition, which is where we have high-level panel, which is where we have, for example, President of Hungary and Tajikistan on board, and they're going to meet here in Geneva in a couple of weeks from now. And here you can see water hotspots, which are the hotspots when it comes to this melting of glacier challenge, like India and Eastern Asia and Central Asia. Then this drought problem in Mediterranean and Middle East, drought problems in Southern Africa and some parts of Australia, and also western parts of both Americas. And we, at the moment, we estimate that it's 2.3 billion people who are exposed to this challenge. And we have a Sustainable Development Goal 6, which is dealing with water, and we are lagging very much behind in implementation of that. And this water challenge and the climate challenge is affecting negatively many of the other Sustainable Development Goals on food security, on economy, and also biosphere. And then, besides this climate challenge, we have also another challenge which is related to population growth. And here we have overlaid water challenge and population growth challenge in one map, and you can see lots of color in Southern Asia, Middle East, and Africa. And especially in Africa, if we're going to have 4 billion inhabitants there besides the current 1 billion, that's going to be quite a challenging area. And also the population growth in India, Pakistan type of countries is a challenge. So there will be a lack of water, and we should also talk more about this population growth control, which has been a little bit hidden thing. And from climate perspective, it means that we would have more victims of climate change because of that challenge, but also we would have more consumers who would potentially cause emissions. If we would only have 1 billion people on the planet, which was the case 100 years ago, we wouldn't have a major climate problem at all, and no major biospheric problems either. Here is an estimation what would happen to the global food production capacity if we would reach 3 degrees warming. And you can see lots of, this is related especially to these changes in the soil moisture conditions and agricultural conditions. And you can see lots of reddish color here, again in southern hemisphere and low latitudes of northern hemisphere, and only a few parts of the world would gain from this 3 degree warming, especially increased rainfall amounts and a longer growing season. And these greenish areas are not most suitable for agriculture, and as a net effect, we would lose global food production capacity. So there's a good reason to not to reach 3 degrees warming. And then let's go to the emission part finally, and thereafter we can have some discussion. And as I said, the main challenge which was shown in one of the earlier graphs is the consumption of fossil energy, which has been causing which is at the moment 86% of the problem, and the rest is related to this land use change, and that's very much deforestation in tropical areas in South America, Africa, and some parts of Asia, like in Indonesia, for example. And here is an estimation of what has happened to the forest area during the past 30 years. You can see that Asia, as a net, is slightly positive, but there are other parts like Indonesia where this deforestation takes place. But for example, China is paying attention to forestation. In Europe, it's fairly balanced, and that's the case also in Oceania, but especially in South America, the Amazonia region, that's a major challenge. And Amazonia region used to be a net sink of carbon in the past, but according to our recent measurements, it has become a source of carbon. And we have also changed the local climate by cutting the rainforest. And also in Africa, that's a challenge, especially in central parts of Africa, deforestation is still continuing. And how about the emissions? Where the emissions are coming from? As I said, 1/3 of the emissions are coming from the richest countries, from the G7 and European Union countries, and you can see that there the emissions have already been dropping a bit, but we have seen a fairly dramatic increase in the emissions of China, where the basis of energy production is very much coal, and this grayish area here tells you about the non-OECD countries, and there we have also seen fairly dramatic growth, and it's countries like Indonesia, Vietnam, for example, where this is Brazil, where that's taking place. And the message from this graph is that we need global efforts to be successful in climate mitigation. It's not enough that the rich countries do something. We have to touch the emissions from all of those country groupings. And this is the challenge in a nutshell. 85% of the energy that we use for energy production, industry, transportation, and housing, it's related to fossil energy. It's coal, oil, and gas. And in case of oil and gas, their consumption is still growing, and we produce only 15% of the global energy based on climate-friendly means, nuclear, hydro, and renewables. The ratio of renewables has been growing, but it's still fairly marginal. And to be successful in climate mitigation, we should bend those numbers during the coming decades. We should start using much more nuclear energy, hydropower, and especially renewables, and also find means to save energy. And at the moment, the main target has been to reduce dramatically the consumption of coal, which was also on the agenda of Glasgow conference. And this is the vision of European Union, how to become carbon neutral by 2050. And here you can see also the magnitudes of various sectors. The biggest source of carbon has been power production, thereafter transport, and third is industry, and then there are some other sectors like residential ones. We have to heat and cool the facilities like this one, and also there are some emissions coming from agriculture, and they're partly methane emissions. And then this dashed area in the bottom is showing the contribution of of carbon sinks, especially forests, and there's a vision that we would slightly increase this sink, and so far we don't have mature carbon removal technologies. It would be great to be able to remove carbon dioxide from the atmosphere, but we don't have very much such technologies available, and that's why this reddish dust number there is fairly low. And the vision is that the emissions should be dropped by 90%, and we could increase the sink a bit by having a bit higher forest coverage, and then there would be still some emissions left for some sectors like transportation or agriculture. And this is debated by the European Commission at the moment. But this is giving you some sort of magnitude scale of the challenge. And one of the challenges that we are having today is that, as I said, the emissions of China have been growing fairly dramatically. But what's happening to the goods that are produced in China, for example, they are very much consumed in rich countries, in Europe, in North America, and also Japan. So that's so it's also us as consumers who are responsible for that. And there's a growing movement at the moment to think of the carbon footprint of products, and that may put some pressure on China type of countries to convert their energy system to be based on, for example, nuclear and renewables in the future. And same is true for fossil energy market. It's very much Russia and Arabic countries which are selling oil and gas and coal, and again they're very much consumed in the rich parts of the world. And then it's a question whether we are hopeless with the climate challenge. And finally, I would like to show you some promising things. We have already seen that there are 32 countries who have been able to decouple economic growth and emission growth. And all these bluish bars here indicate the decrease of the emissions. It's mostly European countries who have been reducing their emissions, but it's also USA and Singapore, for example, Japan here listed. And these reddish bars indicate economic growth during the past 15 years. And for example, Denmark, UK, Finland have been reducing their emissions quite a bit, especially by converting their energy systems to be less based on fossil energy. And so one can say that it's doable. And this is the emission and vision for the warming by the end of this century. As I said, in the 2014 IPCC report, it was estimated that we would see 3 to 5 degree warming by the end of this century. This is not likely anymore. We have been able to start mitigation efforts so far, and in Glasgow we got new pledges on the table, and at the moment we are heading towards about 2.5 degree warming instead of 3 to 5, which was thought earlier. But we are not yet heading towards the Paris 1.5 to 2 degrees targets. So that's why this pressure still exists, and next host of UN climate meeting will be Egypt, and they are just thinking how to be more ambitious. And that's what we are doing also at the UN level. We are making plans how to have more stringent emission reduction means, and especially we are discussing with BRICS countries and some of the G20 countries which are responsible for half of the emissions. And as I said already, these richest countries have indicated positive numbers, and it's a question whether they could even have more ambitious targets. So basically, this 1.5 is very challenging target at the moment, but 2 degrees one could even say that it's a realistic target, but the work needs to continue. And finally, some political dimensions. Thereafter, I'm happy to have some discussion with you. Agriculture is one of the sectors which is very sensitive to climate change, and that will be one of the messages coming from the IPCC report that will be published next Monday. And we expect to see great difficulties in Africa. And in Africa, it's a matter of employment, it's a matter of economy, and it's a matter of survival as well. And in Europe, the southern part is sensitive to this change, which has discussed with one of the colleagues from Portugal, that there has been severe drought during the past years, and this is unfortunately the scenario for the future. And you can see plenty of other countries which are sensitive from that perspective. The former chief economist of World Bank, Sir Nicholas Stern, published his famous Stern report already more than 10 years ago, where he demonstrated that it's up to 20 times cheaper to mitigate climate change than to live with the consequences of climate change. So, and this is of course something that will happen growingly decade by decade, and we have to pay the costs during the coming 20 years. But it's economically viable to invest in climate-friendly technologies. At the moment, there's a tone that half of the climate financing should go to adaptation, and that's also what Egypt, as a host of next COP meeting, is aiming at. And this is not an easy case for oil and gas dependent economies like Russia, where half of the economy is based on sales of fossil energy, and also it's a challenge for Arabic countries. But the tones in the Arabic countries have changed during the past year or so. We heard commitments from Arabic countries, and also Russia indicated interest to mitigate. So it's not hopeless, but it's not an easy case for them. And Africa, with the population growth and less favorable climatic conditions, that's going to be a challenge, and it's also a refugee challenge and potential source of unrest up to wars. And in Europe, especially the southern part of Europe, will suffer in the future, and this immigration challenge is something that we have to also face here. So I think that's all from my side. So thanks a lot for the opportunity to discuss.